Hey guys, it's Miss Parrish. I am coming to you to talk to you guys about our lesson today. We're going to be talking about solving and graphing inequalities. Now, yesterday, if you were in class or if you were watching Miss Klein's video, we kind of introduced the new skill with inequalities. Her lesson talked about writing inequalities and graphing them. So today we're going to take it a step further and we're going to talk about how to solve an inequality problem and then graph it. So the graphing part will look familiar to you because it is just like what we talked about yesterday. But before we can graph anything today, we're going to actually have to solve a problem first. Yesterday, you just practiced graphing an inequality. So today, we're going to solve it and then graph it. So that part, the graphing part, should look familiar to you. Okay. So you will need a sheet of paper. You're going to need to copy down all of the examples. That will be very helpful to you as you do the homework assignment. So it's going to be very important that you know what to do, how to solve these, how to graph them, and what steps to show. So if you need to pause this and get a sheet of paper, please do so. Okay, this is our standard and essential question. Understand solving an equation or inequality is a process of answering a question. How can you solve and graph inequalities? All right, so we're going to do a very quick review that will help us feel prepared for today's lesson. So if you remember when we just finished equations, we spent about a week and a half on equations. So just a quick review, we want to talk about what does the word inverse mean? Well, we've talked about that a lot, and most of the time when I ask that in class, the kids remember what it means. We know inverse means opposite. Okay. Oh, my pen's going to be slow tonight. When we were solving equations, talking about we use the inverse operation to solve those. So solving inequalities is going to be very similar to the process we used for solving equations. We're still going to use the inverse operation to solve an inequality, just like we did with equations. So just as a quick review, let's talk about how we solved equations. For an addition equation, we solved it using the inverse, and the inverse of addition is subtraction. Okay. We solved subtraction equations by using the inverse operation, and the inverse of subtraction is addition. I apologize for my handwriting. I'm having to write straight up on this board and it's a little messy. To solve a multiplication equation, we use the inverse operation of multiplication, which is division. That's getting worse by the minute. Sorry about that. And for division equations, we solved it using its inverse operation, which was multiplication. Okay, so if you can't remember or you struggled with remembering which operation to use to solve, you might want to pause this and write that down because you'll be doing the same thing when we get to these inequality problems in a few minutes. Okay, so just another review on solving those using the inverse. If you'll remember, let's look at this first one. We've got x plus 3 equals 24. So we just said it's an addition equation, so we want to solve it using its inverse operation, which is subtraction. So remember, we were trying to isolate or get that variable by itself. So we want to subtract the number that is on the same side with the variable, in this case, the 3. And so remember, whatever we do to one side, we do to the other. So if I subtract 3 from this side, I subtract 3 from the other side. If you remember, that's going to cancel, and you're left with x equals 24 minus 3 is 21. And then, of course, we checked that by plugging our answer back into the original equation. So 21 plus 3 is supposed to equal 24. 21 plus 3, if you can add that up, is 24. So that one would check out. So to review a subtraction equation, the opposite of subtraction, we've got this one, x minus 5 equals 13. The opposite of subtraction is addition, so we're going to add a number to both sides. Which number are we going to add? Again, you look for the number that's with the variable. So we have the 5, so we want to add 5 to both sides. That's going to cancel. and you have x equals 13 plus 5 is 18. And if we check that, remember the 5 lines, plug 18 in for x, and we have 18 minus 5 should equal 13. Remember we talked about balancing both sides of the equation. 18 minus 5, if you count back or subtract, you do get 13. Now, as I'm going through these, if solving equations was a struggle for you, you might want to write these and work these with me. This is also a good review for the test we've got later this week. The next one we have is 3x equals 15. Now, this, remember, when the number and the letter are touching, that means multiply. So we're going to divide to solve. Division's the inverse operation. We're going to divide both sides by the 3 because the 3 is the number that's with the variable. That is also going to cancel, and you have x equals 15 divided by 3 is 5. So my answer would be 5. And then we're going to check it by plugging the number in. We just said the 3 and the x touching means multiply. So I would have 3 times 5 is supposed to equal 15. 3 times 5 is 15, so that checks out. The next one is a division equation. You have b divided by 2 equals 7. So we would solve this division equation by doing its inverse, doing the inverse operation, which is multiplication. So times 2 times 2, that's going to cancel. And you have b equals 7 times 2 is 14. And then we can always check that one. Plug 14 in for b. 14 divided by 2 is supposed to equal 7. If I do the math, 14 divided by 2 is 7. So that was just kind of a quick review on equations, which we just finished doing. So that should look very familiar to you. Again, if you need to write any of that down, feel free to pause at any time. Now, why did we review that? Well, solving inequalities is just like solving equations. Okay, so that should be somewhat familiar. That part will not be new to you. It's just like solving equations using those inverse operations. The only difference is instead of an equal sign, like you saw here on all of these problems, you're going to have an inequality sign. Okay, so that's the only difference. You're going to solve them just like we did equations, and that's a good thing because we've practiced that a lot. And so that should be familiar, and you're not having to learn a completely brand new skill. So hopefully that will be helpful to you as you solve the inequalities. Now, again, you've got those inequality signs instead of equal signs. So let's review those. We went over these yesterday in class, or Ms. Klein did in the video as well. The inequality signs that we're using. We have the greater than sign, which is pointing to the right. We have underneath that, you have the greater than sign, but you also have that little bar underneath. Okay, if you remember this, you have, let me go back up here with my little arrow. You have the greater than sign. Underneath this, you have the greater than or equal to sign. Okay, so remember when you have that bar underneath, that means or equal to. We talked about that a lot yesterday when we were graphing. Okay, on this side, we have the less than sign, and then below that, you have the less than or equal to sign. Okay, so if you struggle with those, you may want to copy those down just to have those in front of you, and so you'll know what they mean when you get ready to graph one, and that may be helpful. Okay, before we actually graph one of the inequalities, we want to practice solving. So we're going to do a couple of practice problems solving the inequalities, and then we'll do some where we solve it and then graph it. I want us to kind of start out focusing on solving first, okay? And then we can add the graphing in a few minutes. So in your notes, I want you to write this problem down. X plus 7 is greater than or equal to 10. All right, so write that down. Now remember, we just said on the previous slide, we are going to solve this just like equations. Okay, so just think about that. Think about those inverse operations. This is addition. So we're going to solve it using its inverse operation, which is subtraction. So again, don't let the inequality sign throw you. You're going to solve it just like you did an equation. So we're going to subtract from both sides. The 7 is what's with the x, so that's the number that we're going to subtract from both sides, just like we did with equations. So that's going to cancel out. Bring down your x. Now here's the only thing that's different. Instead of equals, look at your sign. It's very important that you pay attention to your inequality sign. And that, ooh, that was not good. Let me see if I can erase that. There we go. You bring down the inequality sign, not an equal sign. This is not an equal sign. You have greater than or equal to. So that's the sign we want to bring down. That's where a lot of people, they get used to putting equals, so they kind of forget that. Bring that inequality sign down, and then 10 minus 7 is 3. So my answer would be x is greater than or equal to 3. Now we're going to check that. So plug 3 in for x. 3 plus 7 is greater than or equal to 10. Add that up. 3 plus 7, that is 10. So 10 is greater than or equal to itself. It is equal to, so that counts. Okay, so again, you're going to solve it just like an equation, except instead of an equal sign, you're going to write the inequality sign right here. So be extra careful of that. Okay, let's try another one. Write this problem down. X is less than, or x minus 3 is less than 9. X minus 3 is less than 9. So this would be subtraction. Again, we're going to solve it just like equations using the inverse operation. What's the opposite of subtraction? It is addition. So since the 3 is over here, I'm going to add the 3 to both sides. That's going to cancel out. And I'm left with x is less than, remember, bring the inequality sign down. You don't have an equal sign. 9 plus 3 is 12. So x is less than 12. Okay, so now we want to check that. That one's not going to check out very good, but that's worked correctly. Okay, because 12 minus 3 is 9. 9 is not less than 9, but that's the answer. 9, 10, 11, 12. Okay, so we'll skip checking that one. Okay, let's go to the next one. 5x is less than or equal to 45. Now again, 5x, 5 and x are touching, so that means multiplication. Okay, so we want to solve a multiplication equation by dividing. So we want to divide both sides by 5, just like we would a regular equation. That's going to cancel, and you have x is greater than or equal to 45 divided by 5 is 9. So my answer would be x is less than or equal to 9. Take a minute. You can pause any of these as you need to. Okay. The last one we're going to practice before we start graphing is a division equation. That way we've done one of each here. X divided by 8 is greater than 3. Okay. So this is division. We want to solve it by doing its inverse operation, which is multiplication. I want to put that little dot there since I have an x as a variable. So we want to multiply by 8. That's going to cancel. X is greater than 8 times 3 is 24. So my answer is 24. Now remember, these are not equals. This is greater than, or this one is, this particular problem is greater than. So you want to use your inequality sign. So x must be, what this is saying is x must be greater than 24 in order to get an answer that is greater than 3. Okay. All right. So that was practicing solving them. So now we're going to take it a step further. We're going to solve these and then we're going to graph them. So again, pull from your knowledge from yesterday where we practiced graphing, and then we're just going to add that to what we just talked about with solving them. So remember from graphing inequalities yesterday, we used an open or closed circle depending on the sign. What we mean by that is if you had just a less than or greater than symbol, then we used an open circle. Okay. If you had the less than or equal to or the greater than or equal to symbol, we used a closed circle, meaning we colored it in. Okay. Excuse me. Let's see. There we go. Now, so the first thing we want to look at when we're graphing is the symbol, does it have the equal to bar under it or not? Okay, let me erase those little circles. I think that's confusing us a little bit. So you want to look at the sign. Remember, if it does not have the equal to bar under your greater than or less than, you have an open circle. If it has the little bar equal to bar underneath, you close it in, you color it in. Then you draw the arrow in the correct direction on the number line to represent the numbers in the solution. We called that the tail. So this diagram here, okay, if you want to copy that down just to have that in front of you from yesterday, or if you've got your notes from yesterday to help you, that's fine. But if you want to write that down on these notes to help you with your assignment, remember, if you have greater than or equal to, there's that equal to bar. We're going to color in the circle. And oops, I apologize. And we said yesterday that as long as your variable is on the left, notice that that symbol is pointing to the right. So that's the direction your tail is going to go. You'll notice the arrows pointing that same way. Less than or equal to, you've got the equal to bar. So you would color in the circle, close it in. This time your arrow is pointing to the left. So you would put your tail to the left. That would be all of the numbers less than or equal to whatever number you're working with in your problem. Your greater than sign, X is greater than. You notice you do not have the equal to bar, so you leave the circle open. Remember, we call that open. It's not colored in. And since it says greater than and it's pointing to the right, your tail goes to the right. And then the less than sign, again, there's no equal to bar, so you would keep your circle open, not colored in. And this is pointing to the numbers less than to the left. So you would draw your tail to the left. Okay, so if you need to copy those down to help yourself, feel free to pause and do that. Okay, so here's our first example that we're going to solve and graph. Okay, so the first thing you have to do is solve it. Just like we did on those previous 4 examples, we have to solve it to get our inequality answer. Then we will take that and graph it. You cannot graph this problem up here. You cannot graph this before you solve it. Okay, so solve first, then graph. So write this problem down. We have n plus 2 is less than or equal to 5. Okay, so let's think about that for a second. That is an addition problem, so we will solve it by using its inverse operation, which is subtraction. And because the 2 is with the variable on the same side, we're going to subtract 2 from both sides. Okay, so that one, as always, will cancel out. And we have n, remember, don't use equals, use your inequality signs. N is less than or equal to, what is 5 minus 2? It is 3. So we have n is less than or equal to 3. So we have solved our problem. Now we want to go over here and graph it. Now you don't have to make a number line from 10 to 10. If you watched Miss Klein's video, you know they used kind of a shortened number line. If you were in class with me, I had my kids, if they were drawing their own, just kind of make a very small number line based on the numbers in my answer. Okay. It was just easier and neater for me to copy and paste this one on here. So that's why I have this one from 10 to 10. Okay. So now we want to graph our inequality. Remember, you take the number in your inequality answer. In this case, we have 3. So we want to go over to the 3 on our number line. Go make sure you're on +3. My answer is a +3. So you should be on +3, not -3. Okay. So the first thing I want to do is look at my inequality signs over here. I have less than or equal to. So when I put the circle on the 3, oops, I don't need to do that. I forgot I've got these little things I can drag and drop down here. Sorry, got used to using my pen. So I need to look at my symbol and decide, do I need to have an open circle or a closed circle? Open circle or closed circle? Look at your symbol. Look back at your notes. Remember, if you have the equal to bar, we use a closed circle. Okay, not sure. I was hoping it would let me move these, but apparently it is not doing it on this. Nope. Well, so we will put a closed, we'll just improvise here. Thought I was doing something fancy. It didn't work out. It's been Monday. It's a Monday. It's okay. You got to be flexible. So we put a closed circle because it's less than or equal to. You have that equal to bar. So we put a closed circle. Okay. A closed circle here. Now I have to decide which way my tail goes. Does it go to the left or does it go to the right? Look at your answer. Remember, we said if the variable's on the left, you can look at which direction your symbol is pointing. Okay. Also, if I know that that means less than 3, then I would want my tail to cover all of the numbers less than 3. If you made your own little short one like this down here, you could just color that circle in and draw your arrow to the left. Okay. Less than's going to go to the left. All right. So solve it, then graph your answer, just like we did yesterday. Okay. Let's try the next one. Y minus 3 is greater than 9. Okay. Y minus 3 is greater than 9. Okay. So it's a subtraction problem. So we want to solve it by using the inverse, which is addition. I'm going to add the 3 to both sides because that's what is with the variable. That's going to cancel. And I have y is greater than 9 plus 3 is 12. Oops, don't have 12 on this number line, do we? 9 plus 3 is 12. So if I had 12 lines on this, I told you guys it's been a Monday. You're watching it on Tuesday, but I'm filming this on Monday night. So y is greater than 12. So I'm going to go to the 12 over here. Now notice, do I have the or equal to line underneath here, or bar as some people said it was? No. So that means I'm going to use an open circle. Do not color it in. It should be open. Okay. And since this says y is greater than 12, notice it's pointing to the right. So I would have my tail going to the right. So if you're drawing your own, you can do 11, 12, 13, put an open circle, and then draw your arrow to the right. It would look actually much neater than this one up here. Okay, solve, then graph. All right, let's do a multiplication equation. Got one of each happening tonight. 10x is less than 80. 10x is less than 80. All right, so this is a multiplication equation. We want to solve it. Oops, goodness gracious. Solve it by doing division. Division is the inverse of multiplication. So we're going to divide both sides by 10. That's going to cancel out. And you have x is less than 80 divided by 10. Guys, if you can count up by tens, you can count up and see that that would be 8. Okay, so x is less than 8. X is less than 8. So I'm going to go over to the 8 on my number line and decide, do I put an open circle or a closed circle? There is not the equal to line underneath. So that means I'm going to put an open circle on the 8. This time it says less than. Notice that my symbol is pointing to the left. So I would go to the left with my arrow. All right, the last one. X divided by 6 is greater than or equal to 7. Ooh, I don't think this number line's going to work. X divided by 6 is greater than or equal to 7. All right. So since this is a division equation, we're going to multiply both sides by 6. That's going to cancel out. And you have X is greater than or equal to 42. 7 times 6 is 42. Now, clearly my number line does not go to 42. Lucky for you, you're drawing your own on your paper. So let's make it easy. So we have 41, 42, and 43. So when I put my circle on 42, look at my signs right here. Do I need to color it in? Will it be closed? Yes, right there is the equal to bar. Those are the ones that tell me to color it in, close it in. So I want to color in my circle. Notice this is greater than, so I want my tail to cover the numbers greater than. It's also pointing to the right, so I would put my tail in that direction. Okay. All right, so that is how you solve and graph an inequality. Okay, remember you're solving them just like equations, so that should be very familiar. All right, the only difference is instead of an equal sign, you write your answer with whatever inequality sign is in your problem. And then you graph it just like we practiced yesterday using the open or closed circle and then putting your tail in the correct direction. Okay. Now, very briefly, I want to touch on one other thing. This is something that's part of this math standard. So we want to make sure that we talk about solutions, okay, solution sets. So I'm going to do just a couple of these. Now, it says, how can you find solutions to inequalities? Well, there's a couple ways. You can use a set of numbers to find a solution, meaning they can give you a set of numbers and you have to plug each one into the inequality to see which one is the correct answer or makes it true. Sometimes they only give you one number. Okay, think back to when we were doing expressions and first started equations. Sometimes they would give us a number to plug in and see if it was true. So that's kind of the same thing here. They give you one number to try. So we're going to practice one of each of these just so you'll know. So in your notes, you might want to write down solutions because this is something in the textbook, they throw this in some, and they could possibly throw this in even on like a TCAP test because this is part of the standard that you're supposed to know. So this first example says, which number is the solution to the inequality? So I want you to write down the inequality. You don't have to put the question mark there next to the 9. Go out of that for a second and take that out. That looks like that's part of the problem. So write down f plus 2 is less than 9. So we want to know which of these three numbers, 6, 7, or 8. So in your notes, put f plus 2 is less than 9. You can say which number is the solution. Then you write down 6, 7, or 8. So what they want us to do when they give you a set of numbers is we have to plug each one in and determine which one, or maybe more than one, could be a solution to the inequality. All right, so we're going to start with the 6. Just start with the first one. So I'm going to plug 6 in for F. Okay, plug 6 in for F. So that would be 6 plus 2 is less than 9. Oops, goodness gracious. I'll tell you what, I have to go to bed. 6 plus 2 is less than 9. So what is 6 plus 2? Well, 6 plus 2 is 8. So bring down your inequality sign. Is 8 less than 9? Yes, it is. 8 is less than 9. So 6 could be a solution. Let's try the others. Sometimes you can have more than one. Now we're going to plug 7 in for our variable f. So 7 plus 2 is less than 9. Well, let's see. What is 7 plus 2? 7 plus 2 is 9. Is 9 less than itself? No, it's equal to itself, but it's not less than. If it had that equal to bar, this would be true, but it doesn't. So that one is, you could say yes, no. So 7 is not a solution. So let's try 8. Plug 8 in for f. 8 plus 2 is less than 9. What is 8 plus 2? Well, it's 10. Is 10 less than 9? No. So the only number that's a solution to this one would be the 6. So that's what we're talking about. If they give you a set of numbers, which one, or sometimes more than one, would be a solution? You just plug each one in to see which one makes the inequality statement true. Okay? Now, the other way is if they give you one number to plug in and you have to decide if that's true. It says, this time it says, is the given value of a solution of the inequality. Now, this goes along with a lot of what we did with expressions in the first part of equations. So write down this problem. This one's kind of written differently. You've got 12 is less than or equal to 18 minus y. If y is 6. They want you to use 6 for y, okay? So I want to rewrite my inequality. 12 is less than or equal to 18 minus 6. So 12 is less than or equal to, what is 18 minus 6? It is 12. So is 12 less than or equal to itself? Well, it's not less than, but it is equal to, and it has that bar there. So this one would be, what is happening? This one would be yes, the solution of y equals 6 is true. Okay, so you're not going to be doing that on your homework, but that, like I said, that is part of what we do in this math standard that goes along with us solving and graphing. So we just wanted you to see that just so you were aware of how to solve that. The bulk of your homework today, oops, I got all the ink off when I had to fix that a minute ago, is what we just did with solving and graphing. Okay, we just did all those examples. Okay, so that's what your homework's going to be. You're going to need to go into your Google Forms or your Google Slides. Mr. Harden was kind enough to convert the worksheet that the students will be doing in class into a Google slide for you guys to work on at home. You will have an inequality to solve and graph. Please show your work for solving the problems on a sheet of paper. There is not a spot on there for you to show your work. So you will need to work all of the problems on paper. I do not have Mr. Harden has not sent me the copy yet, or I was going to show you, but you will show your work on paper and then type your answer into the text box. So if your answer was x is greater than 2, you would type in x is greater than 2. We have put open and closed circles as well as arrows pointing in both directions on the document. So all you have to do is drag and drop those onto your number line in the correct place. Make sure you're noticing whether to have an open or closed circle and which direction to put your arrow for the tail. Okay. Make sure when you submit your Google Slides, you also submit a picture of your work on paper for each of the problems. Remember, you're going to solve those using inverse operations. Keep your notes out. Have those handy to help you as you go through the homework assignment. And as always, guys, you can always message your teacher, whether it's myself, Mr. Harden, or Miss Klein, and ask any questions you may have on this lesson. You can use today's notes, yesterday's notes to help you with the graphing. And I hope this was helpful. I hope you guys have a great day, and we will talk to you soon.